show if you're looking at return on your investment, the best thing you can do in terms of trying to solve climate change is do more research in the field. So education and research turn out to be a key response to climate change. And lastly, I want to introduce to you this gentleman. His name is George Philander. He was the founder of the Access program. He is a South African originally. He was the only black student admitted to UCT to study mathematics in the 1960s. And amid tightening legislation on that sort of thing, he was offered a place to go and study in Yale in the States. And quite sensibly, he didn't come back until after 1994, which you can't really blame him for. And after 1994, he was back for 10 years working at UCT. And he was given a remit of looking at a specific problem. And the problem was that in South Africa, we don't get enough young black South Africans coming into science research. And this is a really big problem that the Department of Science and Technology have identified, because it's limiting our capacity to do science research and therefore the economy. South Africa has a thing called the National Development Plan. The idea is that we go from being a country that extracts stuff and sells it cheap to a country that sells ideas. It's the way that all the other countries that are now rich have developed, right? But to do that, we need the ideas people, and those are science researchers. We need young South Africans to be doing science, but they're not. And so the big problem that George was tasked with was, what do we do about that? And I want to make the point that it's not just for the economy, but actually for young South Africans. There are lots and lots of jobs going in the South African economy that require a scientist. Many, many indeed, more than that, specifically in the government sector, that require a black scientist. I know government in Cape Town that we have a situation where a third of jobs are not filled because they're reserved for a black or female scientist, and there isn't one. So there's a real big opportunity that science offers to develop the South African economy, to actually take individuals into well-paid, stable employment. But not only that, if you think back to my last slide that didn't quite show, to solve problems like climate change. Scientists are the tools we need to do that. And George points out, and I've hinted at this before, that possibly one of the big problems within the field of climate change is that telling people for whom the present is unacceptable that the future will be worse isn't an inspiring message. It's actually cruel. And he suggested we owe young South Africans a better story. And that's why I'm here to advertise to you today. So just to sum up that little part, what does the Fox say? Foxy thinking is really important in climate change, to actually try and, in this interesting space of science, politics, present and future, to think cunning. And science education, it appears, would be one cunning way of thinking about it, because it solves two of the big problems. So the economists argue that we should solve poverty. The environmentalists argue we should solve climate change. We can do both. We don't need to prioritise. And ethical issues mean that an African perspective is important, and at the minute that's not genuinely happening. Generally, the perspectives on offer tend to be Western ones. We don't have a large pool of young, particularly black Africans involved in the climate change negotiations. So, to get educated, oh good grief, I don't do this on my computer, I promise you. We offer a course in Earth System Science at Access. Our predominant offering is at the undergraduate level, but I'm here to tell you today that we've made that undergraduate level course available to anyone in an online format, and I'm going to tell you a little bit about that. The course has been run all over Southern Africa, and in fact in Kenya. So we've gone to Namibia, Kenya, and then all over South Africa. We've been doing it since 2010, funded by the DST. In its most form, it's a 10-day course, targeted at undergraduates. We accepted a couple of postgraduates here and there, where you spend 10 days somewhere in South Africa learning about Earth System Science through a unique combination of lectures, movies, field trips, and activities and games. It's a really, really interesting and different course. And I just wanted to give you an idea of the field of people. The online version is starting soon. It's open to everyone. most of the content is taught online, and then in December we have a workshop in Cape Town where we do the field trips, the activities and that, so you don't miss out on the travel opportunity. We pride it on these values that make it unique. I want to pick up on some of them. We train alumni from the course to teach it. One of the really important things about becoming a researcher is you need to start learning through asking questions, not through being instructed. And it's really difficult to do that if all of your teachers are old white guys with grey hair. They're quite intimidating, so I found that they didn't really get questions if we had those. So I now train people from the course. The course is taught by young people who've been through it and have then come and be trained. It focuses a lot on building confidence. It's a prerequisite to educate yourself in this way. You need to have confidence in yourself to ask those questions, so we focus on that. And developing critical thinking, again, that comes into the peer learning, etc. We teach, this is as roughly the synopsis of the course. It goes to try to understand the reasons the Earth is habitable. And just very quickly, I'm aware I've kept you nearly an hour. Just to quickly outline, I give a talk at the start of the workshop where we look a bit at astronomy and the Big Bang. Why do we have an Earth and not nothing at all? And in that, it transpires that we now know 10,000 different planets around the universe. It's more than that now. It's in excess of 10,000 are known to science. But only one of them is known to be habitable. That's quite an intriguing, observation. I mean, why should only one of them be habitable? So to investigate that question, we have this hierarchy of models. We look at all the factors that go into making the Earth habitable and start to bring out how they interrelate and how they combine together to produce a habitable planet. And it turns out that not one of them can be used to explain it. You need all of them together. And in doing so, we come to quite an amazing revelation. And that's really the story that replaces the in 50 years things will be terrible. It turns out that you are all extremely lucky to live in the most amazing country in the world to be studying this. South Africa transpires to just be an incredible natural laboratory to study Earth system science. So if we want to know about how the Earth works, the heart, the liver and the lungs, one of those organs would definitely be the oceans. And the study of oceanography really explores why are some oceans hot and some cold. We're the only country in the world where you can drive from a cold ocean to a hot in one day, providing an ideal natural laboratory to study that. You need to know something about climate. In some places in the world it rains in winter, in some it rains in summer. I'm sure as you all know in South Africa we're unique in having both. And in fact an area in the middle where it doesn't rain at all. And we've got our own floral kingdom with the highest beta diversity in the world. We've got the big five. I hope you can all get a sense of what I'm saying, but in each case, South Africa turns out to be the best because of its diversity of something, whether it's oceans, climates, animals, plants. So you can kind of conceptualize it as an extended rainbow nation. We're not just stronger because we have a diversity of culture, we're stronger because we have a diversity of everything. And culture is one important part of that, but there's all sorts of different things that go in. So throughout the course we bring up this picture of how South Africa turns out to be the best place, and just so lucky and so advantaged in fact to be able to have this laboratory to study it. I've got millions of these, and a UJ student is actually working on helping me with the problem of how to present them. I've given you 4 there, feedbacks from students, where they say that the best 10 days of my life, I'm now going to do a PhD, it was the best workshop ever, it's one place every young scientist needs to go. I have over 800 statements like this, but I can't show you them all, but otherwise I've got no way to prove that those aren't the only 4. But we have a UJ student who's actually working on bringing me some statistical techniques to show those. But, oh, I forgot my pencil. And the workshops, as today, I hope you will agree, centre on the 3 Fs. What's every student's, apart from the science, they centre on science, but also on the 3 Fs. Aside from the science, every student's favourite 4-letter word beginning with F? You thought the naughty one. Immediately. Of course it's not that, it's free. There are a lot of fun and there's always food. Wow. So you get to travel for free, which is great. It's an important part. It's multidisciplinary. We bring people from all different backgrounds, all different subjects to talk about and discuss these issues. So that's where I am going to leave you today. I'd encourage you that the education, going into research, is the really important thing that you can do to help development, to help poverty, to help climate change. We are a national programme. We do a lot on Facebook. Our Facebook group is very active. If you'd like to go there today and look at the entry for this talk, you can see that there's a scientist who really doesn't like my talk. And that's great, because that's how science evolves, right? I just said it's about constant criticism, and my talk has improved thanks to him. But so you can go and see him and all his criticisms of what actually I haven't said, what he thinks I've said. We've got a brilliant Twitter account. I like Instagram, if people do Instagram with there. We have here taking the video Mr. Dubé. He's the Gauteng rep for Access, so if you have questions about Access, you can just about see his email. But the important one is the one in black, and I'd encourage you all to use right now and to write down. That's how you sign up for our online course. You're all welcome to join. Everyone who signs up can participate. We have local groups get together during the course, and then the top 40 students get to come on a trip to Cape Town. All expenses paid. We won't put you up in a nice hotel, but it'll be a backpackers, which you'll get to come visit the scientifically interesting stuff in Cape Town. Hike up Table Mountain, see the top of Table Mountain. It's a really exciting trip. It's a really exciting course. Thank you for listening to me. I know I've talked too long. It's been a pleasure to come to you, Jay. Thank you.
Thank you very much, Dr. Halma, for an exciting, energetic overview of what this program is all about. I can see the excitement in our students, and I think this has definitely changed your perspectives and enriched your knowledge about science. It is true that we are in need of a lot of scientists in South Africa. Just yesterday, I got a phone call from one major environmental management company looking for 4 atmospheric scientists. So this is a very, very rare skill, but you are well placed in geography, in environmental sciences, in environmental management, energy studies to equip yourself towards that direction. So I would like to thank this group for the time, the investment that they have made to come and elicit this kind of interest amongst our students. I don't know if you've got any questions, any comments that you'd like to make. It has been very animated, very exciting, very thought-provoking. So you might have a comment or a question, something like that.
Hey.
I'm a dropout of the program, the online.
Okay.
Can I still register again?
Absolutely. Yeah, absolutely. So last year you did the program and didn't come to Cape Town.
No, I didn't finish it. A bit of time management failure on my side.
It's worth pointing out, if previous years are anything to go by, it's a really good probability of coming to Cape Town. All you have to do is to complete it, right? Because basically anyone who completed it and answered the questions, vaguely, realistically. There was a couple who obviously were just having a joke. But anybody who answered the question seriously and completed came to Cape Town. I don't think that will be the case this year. I think there is going to be more take-up and more competition. But I still think it represents a really good chance. If you actually just complete the course, you're in with a really good, at least a 50-50 chance of going.
There was that slide that was talking about...
Can you put the lights on so that we can...
Lost my pencil.
Okay. That slide with that long halfway... Yes.
This one.
Yes. About priorities. You get poverty being the reason why we have more infectious diseases and people dying together with air pollution. But climate change also has that the 0.14 million people dying. We can also say that climate change, there's drought there, also contributing to that other 10 million.
No, absolutely, they're interlinked, for sure.
So it was quite an and insight, because you find that climate change has also caused, also contributed to other problems related to poverty, especially drought. And at the end of the day, people are malnourished, they don't have food. So it's actually quite a very inciting.
It is. It's interesting. That's a really interesting problem space, how much climate contributes to droughts. Obviously, how much climate change contributes to famine as a result of droughts, or contributes to deaths as a result of floods. Because obviously those events, right, do cause deaths, but they don't cause deaths in a developed country, right? So a lot of the problem why they cause deaths is actually underdevelopment. And so then on the one hand, you could argue the country should just develop. When I'm being flippant, I tell the story of 2 floods in 2004. There was one in Bangladesh that was a 10-year flood, and one in England that was a 100-year flood, so a flood 10 times more severe. In England, no one died, no one lost their homes, and within a couple of days it was cleaned up and everything was fine. In Bangladesh, the death toll was over 10,000. You might therefore want to conclude that if there are going to be more floods, we better be rich. But I'm being flippant. And you're right, the problems are interlinked. And so.
Personally, Carl, I wouldn't agree with that graph. I mean, like, for obvious reasons. One, I would require you to put, a source, because
World Health Organization is the first one. So this is the source is from Bjorn Lomborg. This is the World Health Organization estimate, which he claims is overestimate. This is his estimate, which he claims is a more realistic one. But either way of those 2 estimates, these are both World Health Organization.
Because, like, if you look at, if you go to World Bank, for example, it will give you a totally different scenario. And I saw you try to put another graph to sort of where you were.
This one.
Yeah, that one. Yeah, because if you go to World Bank and try and look at the highest impact or the greatest fear amongst the people is all about climate change. And so in terms of the past 5 years, climate change or climate change related disasters had been topping in terms of the events with the greatest impact, which are major worries for economy.
This isn't impact.
Yeah.
This is in terms of, so it's the Copenhagen Consensus Project, which is Bjorn Lomborg, this guy that environmentalists hate. They really, really hate him. I've seen him get thrown eggs at conferences. And so he's very controversial. But in the Copenhagen Consensus Project, he got together a group of 20 of the world's top economists. 2 of them have won Nobel Prizes. And he asks them to rate the world's problems in terms of return on investment of solving them. So if you invest money in solving them, how many human lives do you make better? And economists turn that into a number, right? They value each human life as a given number. And so that you can say, if we invest $100, what return do we get on that investment in dollars? Or per dollar investment, what return do we get? And they rate tons of stuff. I've picked out health and biodiversity. The first is that climate change in general, you get very poor return on your investment. But the second observation is that more research is one where you actually get a good return, relatively, although not compared to health up here. That HIV, you would get a much better return in solving that. But in terms of actually trying to do climate change mitigation, reducing our CO2 emissions, you get a negative return. He says it's not worth your money.
Yeah, but look at it the other way, Carl. If you look at, for example, HIV or AIDS, or you want to look at malnutrition, for example, all those diseases that you have mentioned there, climate change actually increases the vulnerability to those kind of incidences. So how then you try and pull them out, it becomes a problem. Because if you say stroke or heart attack, when you have got extreme climate temperatures, you have an increase of those.
Have you seen the recent results with POP? Post-exposure the HIV drugs. The PEP HIV treatment now appears to be principally a vaccine. If you give people the drugs after exposure, they don't get HIV. If you know you've had exposure or you're likely to have exposure, in America now, sex workers are giving them, right? They're just been giving them out because they know that sex workers are high.
Prophylaxis. So you mean if I want to go and indulge, I take prophylaxis. But
Yes.
how many people do have access to prophylaxis? Either post or pre-exposure.
Here's my point.
Not have.
They're very expensive. So instead of wasting your money here, if you'd been putting your money into those, we wouldn't have HIV. We could eradicate it. But the money's being wasted down there. Okay, again, I'm being flippant, but if I was making Bjorn Longberg's case, it won't matter that climate change makes HIV worse because it won't exist. You can do a polio on it, you can remove it from the world if you've got the money, and the money is going elsewhere. Although HIV gets a lot of money.
Oh, this is just to get you thinking, guys. This is what the course is all about. So you've got 10 days of doing that with Carl. So,
sorry, I got here a bit late. So, like, what measures are they taking to reduce the negative impacts of climate change?
Okay, so I didn't specifically talk on that. There are two modes of action that humans are looking at. The one is, the two are discussed there. They're generally called mitigation or adaptation, right? So mitigation is trying to prevent it from happening. And that involves reducing the amount of greenhouse gases that we're producing. The majority of greenhouse gases come from three sources. That is energy, transport, and agriculture, mostly cows. And so at the minute, most of the targets are looking at improving the first two. Specifically building renewable power, building more efficient cars, more efficient cities, etc. And those are being enforced, we hope, by the Paris Agreement. Right? The Conference of the Parties is the mechanism by which we're trying to get agreements as to how everybody can reduce these. But one aspect that I didn't get into, and that is one big sticking point, is as to who has to reduce, how much, and who has to pay compensation. The Western countries produce the most historically, but they are very reluctant to have special treatment, to either have to reduce more or to pay compensation to the developing countries, who have, I think it's South Africa, 0.0001% of the world's historical emissions. We've done nothing. And now we're being punished with everybody else in reduction. The second option is adaptation, and that's learning to live with it. And principally, we're going to have to do some of that because we're already locked in. The CO2 that's in the air will already give us probably 1.5 degrees, if not more, of warming, even if we stopped today. And so that involves building bigger sea defences, building cities that are flood-proof, building cities that are drought-proof. One of the things, I don't know if you saw, a really interesting adaptation that happened in South Africa. We would have been starving in South Africa, or at least paying a lot more for our food, if it wasn't for our government investing in GMOs. So particularly mealies, the South African government specifically invested in GMO mealies this year, ones that could be grown with less water to avert the drought. And that meant that the price of mealies didn't rise. They estimate we saved 9 billion rand in the price of mealies because of that. So those are the two solutions that are proposed. What extent we do one and the other all comes down to lots of the stuff I talked about. Economists tend to want to do more of the adaptation in the future work because they see the discount rate and they think, well, it's going to be much cheaper and much easier to do it in the future. Environmentalists tend to want to do stuff more now because the discount rate doesn't take into account biodiversity, animals, it's just about humans. So the environmentalists will be much more worried, what species are we going to lose? How are ecosystems going to be affected? So the difficulty is in what proportion of both and how do we reach a stable temperature.
But I think for Africa, I think we are worse off because we have already topped the 2 degrees. In some areas, you've got in excess of over 3 degrees. So we already over the top. Whether the Paris Agreement is going to cap that is a big challenge because when it is going to come into effect, we're already in the red. And we have already started losing species. So it's not something that is going to happen, it's happening.
There's another hand.
In your expertise, would you say that last year's drought, the one that happened in 2015, was a result of climate change or was it aggravated by climate change?
you want to take that?
Oh.
Take it.
That's a really good question, and it's a pressing question. There's definitely an aspect of climate change, but there's also definitely an aspect of this El Nino.
Climate variability.
Climate variability. You know El Nino, right? Actually, it's worth pointing out George, who I showed at some point earlier, is an El Nino scientist and a very famous one. Do you know the opposite of El Nino? La Nina. George was the guy to first invent the term La Nina to describe it, so that's a South African invented term, which is a nice thing to know. So El Nino means that the whole of the Pacific Ocean, which is about a third of the Earth's surface, gets very hot. So it's not surprising, therefore, that you would have a very hot year. But then, if you come, okay, I'm using a mouse to insulate myself. If you come to my first slide here, you can see that we're already, this is 1850, we're already in a very, very hot period, right? So this hasn't got 2015-16 on. 2015-16, we went up to 1 degree. So we went up here, right? So look at that scale globally. So we suddenly shot right up here. Now, part of that, right, is because of this general trend. Part of that is because of climate change. But the topic that you're referring to is referred to as attribution. How much of a given event can we blame on climate change? And that's a modelling science in its own right. There's in Pretoria, there's a group that actually work on climate change attribution. How do we say what percentage of an individual event is as a result of climate change? What do you do with that then? I don't know. I mean, let's say we know that it was 40, 60, 80% caused by climate change. Does that influence our thinking?
I think it should influence the way we take action in terms of policy. Because I think there are rumors again that are actually saying we're expecting a bit more rain, but we're expecting a La Nina effect,
yeah.
but it looks like it's not developing as fast as we anticipated. So we might be in another drought. So we really need to save water and adopt CAL's adaptation measure.
Absolutely. Abolish it's pointless, people.
Here's the question. This course that you're offering, at what level is it pitched? Is it undergraduate or is it just an enrichment, knowledge enrichment course?
So
What can students expect?
So it's pitched at undergraduates, but the novelty of the course is not so much in the science presented, but in the linking it together in this coherent story of why the planet's habitable. So for example, in the first lecture, we look and we say, well, as a first approximation, Mars is too cold, Venus is too hot. Mars is furthest from